This is the lesson here. We're going to cover the derivative of exponential functions. Okay, so given y equals, and in particular, we're going to be dealing with the natural exponential function. So has an exponential function with base e, the natural base. So given y equals e to the x, all right, y prime, okay, this is as simple as it gets, e to the x. So here we have a function whose derivative is itself. Okay. So y equals e to the x, the derivative of y prime is equal to also e to the x. And like when we did with the natural log functions, this is a specific exponential function e to the x. More generally, given y equals e to the u, right? So now what is u? U is equal to some function of x, whatever it may be. Now in this case, what's y prime going to be equal to? It's going to be equal to e to the u. So looks similar, but then times the derivative of u prime, right? So another way to think about this is what's the derivative of e to a power? Well, it's going to be e to the power times the derivative of my power, my exponent. Okay, so this is really the one we should focus on. If you apply it over here, right, you get, well, what's the derivative of e to the power of x? Well, it's e to the power of x times the derivative of x, which is 1. Okay, so that's why we don't see it. All right, so let's go ahead and do just a couple examples of this. This is pretty simple. Make sure one of the couple big things here is you represent, your derivative correctly. Okay, so a couple little examples finding derivatives. All right, I want to find y prime here in this case. So y prime equals what? That's what we're after. So first one, given y equals e to the x squared. All right, what's y prime equal? Well, here we go. Y prime is equal to e to the x squared. E to the u is going to be e to the x squared times then the derivative of x squared, which is 2x. Done. There's y prime. Okay, 2, y equals e to the x cubed plus 3x. Okay, what's the derivative of y equals e to the x cubed plus 3x? Well, not a whole lot different. What's the e to the u, e to a power? It's going to be, well, e to the power. So e to the x cubed plus 3x. Then times the derivative of that exponent x cubed plus 3x, which is what? 3x squared plus 3x. Now, at first, I'm going to write down incorrectly. So this is what sometimes I see, which is not representing the derivative correctly. Here we have e to the u times part of the derivative of my exponent. Make sure we put it in parentheses. Now we're correct. Okay. So there's y prime in that case. All right. Let's go with one more here. Okay. Y equals e to the cosine of x. All right. So if y is equal to e to the cosine of x, then y prime would be the derivative of the e to the cosine of x. Right. So times then the derivative of cosine times, good idea, times, put in parentheses, negative derivative of cosine, negative sine of x. Okay, so there's that one. See, pretty simple to take the derivative of e to a power. Okay, it's just going to be your function, e to the power, then times the derivative of your exponent. If we go over to now here, so find y prime, right? So solve for y prime. Okay. So what do we got? We could try to solve this for y. That's going to be difficult, but we don't necessarily need to. We don't have to. We can use implicit differentiation. If I could solve for y, I would have y as a function of x, or pieces that would be function of x. So whether I take the derivative of y now or after I solve for y, doesn't matter. So we might as well take the derivative as is. All right, so here we have d dx of everything on the left, and then the derivative on the right. Over here, careful, because this is where we got to make sure we do this correctly. What's the derivative of e to the x plus y? Well, the derivative of e to the x plus y is going to be e to the x plus y, but then times the derivative of, so here we go. Put in parentheses. What's the derivative of x? 1. plus the derivative of y prime, minus the derivative of 3x with respect to x equals 0. Okay. Now in this case, we want to solve for y prime. So, sometimes just because of the nature of how this looks, that the complication of solving for y prime becomes more difficult. It really shouldn't be. If I gave you this problem, no one would have a problem solving for x here. Okay. If you solve for x, there's really would be, I think, two ways you could go about doing it. One would be to distribute and get 2 plus 2x minus 3 equals 0, and then solve for x. Another one would be to first add the 3 over, divide by 2, kind of get this, and then solve for x there, right? So you gotta think, what could I do? I could distribute first, then solve for x. Or I might add the 3 over, divide by 2, and then solve for x, right? And that's the same thing down here. All right, what might you do? You might distribute the e to the x plus y first, and then solve for y prime. Or maybe you add the 3 over, divide by the e to the x plus y, and then get rid of the 1. All right, so let's do that one that way. All right, it might not look nice in the end, so we're going to add 3 over, divide by e to the x plus y, so we have y prime plus 1 equals 3 divided by e to the x plus y, and then to solve for y prime, clearly that would mean y prime is equal to 3 over e to the x plus y, and then minus 1, right? Right neatly. All right, so there we have the derivative of an exponential function. We have some implicit differentiation going on. Okay, so that's all there really is to that. Don't overcomplicate that there. Okay. So that's essentially it there with finding the derivatives of e to a power. Okay. If there's other stuff that we got to do, and there will be other stuff we have to do, whether it be finding the slope at a particular point. Well, if we have to find the slope at a particular point here, okay, so then we plug in the value for x and y, right? And we find the value of y prime. If we have to find the equation of the tangent line, all right, we've done that. We need the slope, which is y prime. Find the value of y prime, which is the slope. You have the point. You have your point and slope. Find the equation of a line. Okay, so not a whole lot changes there in terms of doing some of that stuff. Okay. Keep in mind some basic properties. Just, if this is your, could be, sorry, I'm going to do something like that, this would be more complicated, but realize that, well, e to the ln of x, right? Those are inverse functions, exponential function base e, logarithm base e, right? So keep in mind that this y equals e to the ln of x, that's just the same as x, right? So if you find the derivative here, well, one option would be, what's the derivative of e to the ln of x? Well, it's e to the ln of x times the derivative of my exponent right here, ln of x, which is 1 over x, right? Or that's going to be equal to the derivative of x, which is just 1. So obviously it would be simpler to recognize that this, right, simplifies to x first and then take the derivative of x, which is 1, right? So both are correct, but clearly this one is much simpler. Okay. So that takes care of the exponential function for the most part, right? There'll be stuff that gets added on, and but in terms of just basic derivative of exponential with base e, that's all there is to it. Shouldn't be too complicated. Don't overcomplicate it, right? You got e to the u. What's the e to the u? E to the u times u prime. Okay. One of the little things is that you represent it incorrectly. Like I said over here, if you keep out the parentheses, it's wrong. Okay, because you're not multiplying by the whole derivative of the exponent. It's only part of it. Okay, so keep that in mind. Watch this over. Got any questions on anything, let me know.